now know, but I can't
Well, I mean, you're not
cover
gonna get a bad
something.
grade for it, so.
You should hold a grudge.
That means we can't be like obnoxious for no.
You shouldn't be obnoxious anyway, Jake.
Oh, she said my name.
Yep.
She was talking about if or long. I think we can do it. Cool.
Okay. What we're covering today, what I actually have on here, we're starting 5.4 is the fundamental theorem of calculus. There's 2 parts to it. I'm not actually defining what the fundamental theorem of calculus is today. We're just going to talk about what it is, roughly a general idea, and then before actually looking at the fundamental theorem of calculus, you have to know what an area function is and how to work with an area function. There is always a free response question on the AP test that deals with an area function. So I have last year's free response question on here. I want to go through some of these parts you've already seen. It might have been on the final exam review first semester. There were a couple parts that you could have answered before now, but after knowing what after what we learned today, you're going to see how to answer the parts you wouldn't have been able to answer before. So the new... This is f prime though. So f is differentiable. This is, yeah. So f prime would not be differentiable everywhere on that interval. Okay, so the fundamental theorem of calculus connects the branches of calculus we study, differential calculus and integral calculus, and it talks about how they are inverse processes. So if you haven't realized that already, when you find an integral, you're finding the antiderivative. It's the inverse process of taking the derivative. So this is, in general, this is not the formal outline of what the fundamental theorem says. It has 2 parts. Part 1 says that if you take the derivative of an integral, so if you integrate a function and then you take the derivative, it's going to get you back to the original function. And then part 2 is the opposite. If you take the integral of a derivative, so you find the derivative and then you take the integral, it's again going to get you back to the original function. So it's just talking about how they're inverse processes, just like addition, subtraction, multiplication, division, they undo each other in a way. But part 1 deals with an area function, so you need to be familiar with this type of function and know how to work with it. So if you see a function of this form, g of x is the integral from a to x of f of t dt, so I know there's multiple variables going on. What I want you to realize though is x, so g is dependent on x, and x is the upper limit of that integral. So f, just right now, the function that's in the integral is with respect to a different variable, but the actual function g is dependent on x. And then there's a graph to go along with this over here so you understand what this is. So some things about this type of function. Y equals f of t is a continuous function on the interval from a to b. And then x, so that upper limit of integration, is varying between a and b. So if you look at this, the reason why it's called an area function, we know that the integral from a to b would represent the area between the curve and the x-axis from a to b. And then since x is varying between a and b, that would make the area from a to x varying. And that's what makes that a function, since it's no longer just a definite number. So g of x depends only on x, as I was saying before. If x is a fixed number, if you know the number x is, then the integral would be a definite number. But if x is just left as a variable, then the area is also varying like I was talking about, and that's where you get a function for g. One other thing I want to point out with this, when you find an integral, say you're finding or you're evaluating a definite integral, what do you have to find in order to evaluate an integral? The function, yeah, so like if we had like x squared here, what would you have to find before you could plug numbers in? Antiderivative. So if g of x is equal to the integral of f, that means g of x must be an antiderivative of f. So that's important for you to realize, because if g is an antiderivative of f, that means if you are given the graph of f, that is also representing the graph of g prime. So if g is an antiderivative, that means f is really equal to the derivative of g. It's equal to g prime. So that's kind of key when you're working through problems like this. You're kind of going back and reviewing relationships between a derivative or the graph of a derivative to then answer questions about the original function. That's part of it that we'll kind of reference here. So looking at this first example, it says if f is the function whose graph is shown. So again, if this is the graph of f, we can also think of this as the graph of g prime. But f is the function whose graph is shown. G of x is equal to the integral from 0 to x of f of t dt. And it says find the values of g of 0, g of 1, g of 2, g of 3, g of 4, and g of 5, and sketch a rough graph of g. So we're going to start out finding g of 0. So this is kind of the new part for today. And then what I have after this is then using this relationship or manipulating it different ways to answer different questions. But to find g of 0, that means in this function, this integral, your upper limit x becomes whatever value it is you're substituting in. So you're substituting the upper limit of the integral. So I'm finding the integral from 0 to 0 of f of t dt, yes, which is just 0. Okay, so then if I'm finding g of 1, I'm finding the integral from 0 to 1 of f of t dt. How would I find that without knowing what function f is? Well, so if I wanted to find this, I would need to know the antiderivative of f. So I would need like an expression for the antiderivative of f or for g, which I don't have. So because I have the graph, I know the integral represents the area. So I can find on the graph the area from 0 to 1 between the curve and the x-axis because it makes a triangle. So 1/2 base times height, I would have 1/2 times the base is 1, the height is 2. So it would just be 1. That area is 1, so g of 1 is just 1. So again, that's why it's called the area function, because you can use area to then find function values. So then g of 2, I'm going to go from 0 to 2 of f of t dt. So we would have still the area from 0 to 1. Now we need the area from 1 to 2, which would be 2. A rectangle, that's 1 by 2. So yes, that would be 1 plus 2, which is 3. And then, so now for here, for g of 3, because this is not, this curve is now not linear, so it's not exactly a triangle, so you can estimate what it would be. We still have the integral from 0 to 3. So yeah, it's a little more than 1, because it's a little more than that triangle that we had over here. So 1.25 we could say. So it's an estimation. So we would have 1 plus 2 plus 1.25, so about 4.25. And then we have 2 more, g of 4. So this 2, yes. So it is 1.25. If that's what we're going to use, it would be the same area that was up here, but it's below, so it's negative. So now our value is actually just 3. We're back to 3. And the last one, g of 5. Another negative 1.25, so it'd be the 3 minus another one. 1.75. Okay, so finding values is one thing. Any questions on that? Just using the area to find values. Then it did say to sketch a rough graph of G. So what you can do is you can use these as points. So then I know I have the point 0, 0 on the graph of G, the point 1, 1, the point 2, 3, 3, and then approximately 4.25, 4, 3, and 5, 1.75 approximately. I'm just going to sketch it below. And I'll just plot those points and then draw a smooth curve in between them. And it's just on the interval. We're just going off of the 0 to 5 because we don't know anything past that, but we could see the graph of f on this grid doesn't extend past 0 and 5. And then, so just sketching this partly is, again, to help us think of relationships or see the relationships between f and then our function g. So it says, on what intervals is g increasing and decreasing? So we can see from the graph that we just made, and then also from the values we found, that g is increasing from 0 to 3, and then decreasing from 3 to 5. But what I also want to show you, and this is going off of the fact that g is an antiderivative for f, so if you have the graph of f, this is really the graph of g prime. Remember, if g is increasing, that means g prime is positive. And if you look at the graph, you see that this graph is positive from 0 to 3. And then it's negative from 3 to 5. So that relationship that we first talked about in chapter 2 is still applying here. You just have to recognize that. And then it says, where does g have a maximum value? And that would be at where? What did you say? Oh, I thought you were answering the question I asked. So g has a maximum value at 3. So g of 3, which was approximately 4.25. But you can see again, so a maximum would occur when a derivative is changing from positive to negative, because that means the function is changing from increasing to decreasing, and we can see that that does happen at 3 on the graph of f. So are there any questions on this? Okay, so then what I have for the next piece, so part of this I'm going to have you work on, and then we'll just double check that we're all on the same page. But it says, let f be the function graphed below, and let g of x equal the integral from 2 to x. So here you have to pay attention when you have these area functions. They don't always have to start at 0 or have 0 as the lower limit. This lower limit is 2. So we have the integral from 2 to x of f of t dt. And then it says evaluate each of the following. So I just want to look at g of 0 with you. If we were to find g of 0, 0 is being substituted in for the upper limit. So we would have the integral from 2 to 0 of f of t dt. Now, normally, when you have an integral, your limits of integration, your lower limit is on the bottom, like the lower values on the bottom. Yes. Why? Yes, you're going backwards, or if you think the properties of, or by properties of integrals, you are allowed to switch these to make it 0 to 2, but if you switch them, the integral has the opposite value. So you would still find the area from 0 to 2, which is 4, for that rectangle, or actually that's a square there, but it would then be negative 4. You're surprised what? Oh. I just wanted to see why you knew it was negative 4. So I want you to find... I'll give you a couple minutes here at least. Answer through F. So find the values. And then you can, if you're waiting, work ahead. But I just want to make sure that what you're putting for justifications for those, that's also something I wanted to talk about today, is making sure what you're writing for justifications on your AP test is what they're looking for. So at least answer through F. And then we'll check those.
No, man. You didn't give up on me, Mr. Studio?
I never gave up on you, Jim. All right, double check. Not all of you were done with all of them when I walked around. Actually, I could probably show my graph here. Any questions on those? So E and F, I think, well, some of you hadn't answered them yet when I walked around. But because it's G prime, remember G prime is F. So G prime of 4 would just be F of 4. So you find the function value at 4. So you had the answers, but you didn't actually know why they were right.
Yeah. He told me how to find it.
Okay. Well, if you need to, maybe make a note of why. Just say this is equal to F of 4, this is equal to F of 7. Any questions on those? Some of you I know started looking ahead. I just want to make sure you have the correct reasonings for these next ones. So what would you say is the maximum of G on the interval from 0 to 9? G of 7, yes. So, and again, when it asks what is the maximum, it's really looking for the Y value, but as long as you say, like if you said G of 7 equals and then the value that it is, so what would G of 7 be? 9.5. You're not including this. Because remember, G starts at 2. G starts at 2. If you start it from 0, then this 4... No, don't start it from 0. Well, it's still on the interval from 0 to 9, but G is defined to start at 2. So you wouldn't include this rectangle here. Okay, so G of 7 is 9.5. Is the maximum. Now, when it says justify, how do you know it's a maximum? The derivative is, the derivative is going from positive to negative, meaning the function is going from increasing to decreasing. So this is how you can phrase it. because we're given the graph of f, if you're referring to the graph and you're talking about the graph being g prime, you have to state that you know that. So I would say g of 7 equals 9.5 is the maximum because I'm going to say f equals g prime. So that way if I'm referencing, or I'm making a connection between what is happening with the derivative and then what I know about g. So I need to establish that I know f is the derivative of g. So because f equals g prime, and then I can say f is greater than 0, so it's positive, and I'm going to say f is greater than 0 on the interval from 0 to 7, because we're talking about the interval 0 to 9. If you're finding a value for g, though, you have to go off of how g is defined. G starts at 2. The interval they're referencing is 0 to 9. So all the way from 0 to 7, the derivative, or f, is positive. And then I would say, and f is less than 0 on the interval from 7 to 9. And because they have a closed interval here, that's why I'm including the brackets on the 0 and the 9. The 7, though, is where I'm saying at 7 we know it's 0. I'm showing that it's the derivative, f is g prime, so the derivative is changing from positive to negative on, or at 7. Okay, so this is a better reasoning than just saying in words, because there is a 0 at 7 and the graph is changing from positive to negative. So rather than saying that in words, this would be a better way to phrase that. Okay? The minimum of g on 0 to 9 would be what? At 2, like g of 2. G of 2 is not the minimum. G of 0 is the minimum, because g of 0 is negative 4. So g, you're on the interval from 0 to 9.
Then how is I know they changed it up on it.
How is what not 13.5? Okay, if you're finding, so when you found these values up here, you started at 2. G, to find a function value for g, you're starting at 2. They're still referencing, though, the interval 0 to 9. G of 2 is 0. G of 0 is negative 4. This is smaller. Right? This is still starting at 2, but because g starts at 2, g of 0, that's why it's negative. So because you're going backwards, yes.
When we were finding the maximum, how come we didn't subtract class 4?
Because g of 7 equals the integral from 2 to 7. Does that make sense? Kai, did you have a question? Guys, can you be quiet so I can hear Kai's question? Yes, because when it says the minimum, it's referencing absolute. So an absolute could be the endpoint. Yep. Yes, if it just says the minimum, it's referencing absolute. If it wants just local or relative, it would have to say that. Yep. So g of 0 equals negative 4 is the minimum. I just want to talk about this reasoning quickly with you. It's similar reasoning to up here. Well, what I had said for the minimum, I said because we know since, I'll phrase it this way. So because f, again, I know is g prime. So I know if the derivative is positive, the function is increasing. So I know g is increasing from 0 to 7. And then it doesn't decrease until 7 to 9. But I know g of 9, and it's not smaller than g of 0. So that's how I'm saying I know that this is the minimum. So g of 0 equals -4 is the minimum because f equals g prime. And f is positive on 0 to 7. And f is negative on 7 to 9. But g of 9 equals 7.5. Therefore, g of 9 is greater than g of 0, just to show how I know that g of 0 would be the smaller. How can you tell where g would be concave down? Yes, so here, your justification though, this is another thing, if you're given the graph of f, your justification should include what about f do you know. So if the derivative of f is decreasing, or the derivative of f is negative, that's because f is decreasing, right? When f decreases, its derivative is negative. Yes. So your reasoning should be because f is decreasing, not because f prime is negative. Because you're not given anything about f prime. You'd still have to phrase f prime is negative because f is decreasing. So you'd just be stating more information than you needed. That's why I'm going through these with you, so you can see how to justify. So where is g concave down? On 4 to 9.
Yes, thank you.
On 4 to 9, I'm just going to make this short here because and f is decreasing, yes.
Did I get like 1 point on
Usually if it asks for a justification, like this would probably be a 2-point question. 1 point if you got the interval right, and then 2nd point for your reasoning. So usually if you still have the right answer, you get some credit. I do want to get to at least part A of the next, well, yes, at least part A. But for J, when it says write the equation of the tangent line, just to discuss how would you do that? Tangent line 2g at x equals 4. So you said you need the slope. The slope would be what? G prime of 4. So the slope is g prime of 4, which you found, which is 3. And then you're using the point. What point are you using? Yep, g of 4 you found was 5. So your point is 4, 5. So y minus 5 equals 3 times x minus 4. Or y equals 3x minus 7. Tangent lines don't go away. So the last question is, like I said, it was question 3 on last year's AP test. And although if you kind of look at the question, nowhere do you see an area function at all. I just wanted to show you because this comes up often. By often, I mean like you could probably expect it to come up on the AP test, having to do this. So you have seen part of this question you've already answered, and I know you might not remember exactly, but you were able to answer part B and part D prior to today. I think I had those two on your final exam review for semester 1. So it says the function f is differentiable on the closed interval -6 to 5 and satisfies f of -2 is 7. The graph of f prime, the derivative of f, consists of a semicircle and 3 line segments as shown in the figure above. So this is f prime that's graphed. And part A says find the values of f of -6 and f of 5. Okay, and all we're given about f, we're given the graph of the derivative and we're given that f of -2 is 7. Now, f we know, compared to f prime, f would be the antiderivative. So we would be able to set up an integral to help us find the value f of -6. So I just want to show you how to work with this. Because we're given the function value at -2, and we're trying to find the function value at -6, I'm going to set up the integral from -6 to -2. And it's going to be the integral of f prime. And I'm using the integral of f prime because I have the graph of f prime, and I can find the integral by finding the area. So I do know, though, by what we talked about, it was called the evaluation theorem, I know that this integral would be the antiderivative of f prime, so it would be f of x evaluated from -6 to -2, meaning it would be f of -2 minus f of -6. All right, do you have a question? Yep, that's why it's on the bottom. No, the bottom one should be the smaller one. So here I have, if I kind of cut out this middle part, I have this integral, which I should be able to find from the graph. I already know f of -2, so I have now set up an equation that would allow me to solve for f of -6. Okay, so if I look at this graph from -6 to -2, so it would be this triangle here, that area would be, let's see, we have a base of 4, height of 2, so 8 divided by 2, so that area would be 4. So this integral is equal to 4, but I also know it's equal to f of -2 minus f of -6. f of -2 is 7. And then f of -6, I don't know. That's what I'm trying to find. So here, based on this equation, if I solve for f of -6, so I could subtract 7, and that would equal the opposite. So f of -6 is 3. I have found a function value by setting up an equation that involves an integral, and that does come up. Does that make sense how I got that? So then you could find f of 5. You could find f of 5 that same way. What I also want to talk about, though, so I'm just going to leave this. If you wanted to find f of 5, I'll just give you what, I'll give you what it should be, and if you want to see if you're able to get that, you can. It should be, because this would be a no calculator question, it does say that at the top, it'd be 10 minus 2 pi. You wouldn't be able to get a, without a calculator, a better approximation than that. Just leave it exact. Same process, yep. So if you want to, I'm just giving you the answer if you want to make sure you could get that. That's up to you. But then for part C, this one I also want to talk about. This was actually covered last chapter. But it says find the absolute minimum value of f on the closed interval from -6 to 5. So think back to chapter 4. If you're looking for the absolute minimum or maximum on a closed interval of a function, where do you look? Well, we don't have the graph of f, though. For C.
Oh.
Where could an absolute minimum occur?
2.
At an endpoint. And the critical values. Yes, we have the endpoint. So what I'm doing is I would show for part C, I would set up a table. Well, you wouldn't have to show it this way. I would set up a table, though, and say, okay, I'm going to find the function value at each of the endpoints, which you actually did in part A. So I know f of -6 is 3. I know f of 5. I know I just gave you the answer. I didn't show it. But you'd find it that same way. It's 10 minus 2 pi. But then an absolute minimum could also occur at a critical value. What is a critical value?
0.
So a critical value is when f prime is 0 or undefined, but we're already told in the problem that f is differentiable on -6 to 5, so the derivative exists everywhere on -6 to 5. And f prime is 0 at -2 and +2. Okay, so I would have to find, actually I'm given f of -2, which is 7. That was given to me in the problem. I would have to find f of 2, and then whichever y value is the smallest would be the absolute minimum. Okay, so I just wanted to talk about how to do that. You would find f of 2 the same way we found f of -6 in part A, the same way you would find f of 5 in part A. I know that was quick, but are there questions on A or C?